So let's answer a couple from worksheet 4. Number 14, let's get tangent of x over 2 by itself first. So subtract the 3, divide by this 3, tangent of x over 2 equals negative 1. So don't worry about the x over 2 yet, but do worry about where is tangent equal to negative 1. Where is tangent equal to negative 1? Negative pi over 4. That's and then how do I get all the other answers? Plus pi k. Now, because we're going for all the answers, you don't have to pick negative pi over 4. You could have picked 3 pi over 4. And you could have even picked, see if I can get there, all the way around, 7 pi over 4. Any of those are okay places to start, because when we add pi k, we get all the others. So take your pick, whichever one you see first will work for an equation. Now, if this was an inverse tangent problem, we'd have to pick this one, which is why I picked it. But since we're getting all of them, you could have picked any of them. So that's what I need x over 2 to equal. I need x over 2 to be negative pi over 4. So what do I need to do to get x by itself? Multiply everybody by 2. So x equals negative pi over 2 plus 2 pi k. And that would get all of the answers. What other questions from that worksheet? Number 11. All right, number 11. Cotangent and cosine squared, don't really like that, but if I subtract the cotangent over, then I can factor out the cotangent, and it's not so much a problem anymore. Factor out cotangent of x. That leaves cosine squared x minus 2 equals 0. So I'll set them both equal to 0. So cotangent of x equals 0. Cosine squared x minus 2 equals 0. And again, this is always what factoring does. It takes an impossible problem and turns it into two easier problems. Maybe not easy problems, but easier, workable, I can handle this. Cotangent of x equals 0. How do you want to handle that? What's that? You can, because if you flip 0, what do you get? So we can turn it into a tangent. That is a completely okay to work this way to work this problem. And what happens when you do 1 over 0? That's undefined. This is still going to work, but now I need to know where is tangent undefined. So it doesn't mean my problem is over. It just means where is tangent undefined. I think, well, I don't really know right off the top of my head where tangent is undefined. But I know that tangent is sine over cosine. So where is cosine 0 is maybe the next question to ask. Because if cosine is 0, then we're dividing by 0, and that won't work. So eventually I've got to ask, where is cosine equal to 0 at, let's see, that would be the x-coordinate being 0. So that would be pi over 2 and negative pi over 2. So I'm going to be sneaky and save space and just say plus or minus pi over 2. plus 2 pi k. And that fits the cosine rule anyway, right? If you find one cosine answer, the other answer is plus or minus whatever you got. So even though this isn't a calculator problem, the plus or minus rule still works. Right, the other way we could have worked this problem is, like, that's probably what I would have done because we don't really like cotangent. But you could have written cosine or cotangent as cosine over sine. And the only place cosine over sine is equal to 0 is if cosine is 0. So any way you go, you end up asking or trying to figure out where is cosine 0. Whether you do it as a cotangent problem or a tangent problem, cosine equals 0 is the ultimate solution here to that. I still need to get back and go get this part. Yeah. So that's the only answer for this side.
Hello, I'm
Good.
going to pick up Caleb. You're supposed to be in the library this moment.
I talked it over with my parents and we figured out, I don't know if we told y'all, but.
You did not, because I'm.
Right, so the second part of the problem is cosine squared x equals 2. So cosine squared x equals 2. Oops, I said the next step without writing it down. Move the 2 over. Square root both sides. Put the plus or minus on there. Cosine of x equals plus or minus square root of 2. That almost looks like unit circle, but not quite. And there's nothing I can do to fix that. Now, I know that that's not going to work because cosine has to give me an answer between -1 and 1. But even if I didn't know that, I'd go to the calculator and do inverse cosine square root of 2. And it says that doesn't work. Error. I can't do that. So there's no solutions for this side of the problem. Be careful with that. Don't box no solution, because for problem number 11, there are solutions. They're just right here. There aren't any solutions to this piece of the problem. So if you box it, I'm not going to count it wrong. But if you only box no solution, I would count it wrong, because that's not exactly correct. All of the solutions come from this part of the problem. So that's just a little bit tricky thing on what does no solution mean. There's no solution to this, but there is a solution to number 11. A lot of solutions to number 11. Let's look at number 10. I don't like looking at number 10, right? Tangent squared and secant. I can't do anything with that. I do remember that there's an identity with both of those in there. In fact, I must have used it for a different one close by, because there it is. Tangent squared plus 1 equals secant squared. But you could look that up in your notes, or you could figure it out. I want to replace, well, you tell me, in number 10, what do I want to replace? The tangent squared. I can't really replace secant because it's not squared. So tangent squared, if I rearrange the identity here, is secant squared minus 1. So in place of tangent squared, we'll put secant squared x minus 1. Everything else stays the same. So secant squared x minus secant of x minus 2 equals 0. You can use substitute and factor with u's if you'd rather. I think most of you are probably okay factoring on the fly with trig functions, especially when it's not too difficult. It's got to be 2 and 1. It's got to be plus and minus in order to make that a -2. And I need the middle term to be negative, so I want minus 2 and plus 1. So split those up. Secant of x plus 1 equals 0. Secant of x minus 2 equals 0. And again, as always, this is what factoring does. It takes a really impossible problem and turns it into two easier problems. So secant of x equals negative 1. And secant of x equals 2. But I don't really like secant problems. What would I rather work? Cosine problems. So let's do the flips here. And so let's say cosine of x equals, what happens when I flip negative 1? It stays the same. So that one's a little bit weird. It feels like it didn't do anything. Because when you flip negative 1, you end up with negative 1. Cosine of x equals 1/2. So let's see here. Color code my answers so we know where they came from. Cosine of x equals negative 1. That would be over there. Right, that visually helps me more than memorizing. Cosine of x is negative 1 over there, and over there would be at pi. And it's only one spot, it's not two places like usual. Usually we put plus or minus for our cosine answers, but plus or minus pi lands me at the same place, so I don't really need a plus or minus on there. And then cosine x equals 1/2. Let's see, cosine's positive in the first and third, or excuse me, first and fourth. Cosine of x is 1/2 at, let's see, that's 1/2 is the short side, cosine is the x length, so pi over 3. And if I can just put the plus or minus on there, that will get both of them. Speaking of the plus or minus, so we saw the tangent rule already today. That's just plus pi k. The cosine rule is plus or minus. What's the sine rule? If you know one answer, how do you get the other answer? Well, careful. Pi minus the answer. Pi minus the one that you know for sine.